Hello everyone, and today we are going to solve climbing stairs problem, which is a very famous problem which builds your foundation in DP and recursion. And it's a very easy problem, and I am sure you will be easily able to understand this properly. So what's the problem says? Actually, the problem says that there are like n steps, and we are given that in each step we can either climb one step or we can either climb two steps. So there are two possible conditions: either we can climb one step or two steps. So we have to solve our problem based on this condition given to us. So in our mind, what is coming to us first? Like, what should we do? Like, we need to go one step and two step. So if we are starting from 0 and we need to go to n, then we need one indexing for 0 to for going from 0 to n. So for that we can write one helper function. So we can have one helper function which can go from n to n, and we'll pass the index to 0, and then we will be defining our helper function here. Here int n and int index, we are passing two parameters, and we will do very simple thing. We need to return all the possible distinct ways to climb n steps through one step and two steps. So helper function, and we need to climb one step first. So for one step we will need to write index plus 1, and for two step we need to do index plus 2 because we are climbing to second step. And whenever we will find that our index becomes equal to n, we need to return 1. Why n? Because when we reach n, we found out that there is one possible solution from these steps this way, and we need to take care of one edge cases, that there might be some cases with plus 1 there will be no cases, but there for plus 2 there might be cases that index is at n minus 1 step, and plus 2 will be greater than the index. If in index n minus 1 stage and we need to reach the n, then with index plus 1 we can reach the n, but with index plus 2 it will be greater than n. So what we need to do here is we need to take care of the edge cases for going greater than n. So we need to return here 0. So that's it will solve our problem. But this solution will take 2 to the power n time complexity, as because two different recursive calls are happening. So we can decrease it to linear time complexity through memoization. So what is memoization is, like, if there are many overlapping subproblems, for suppose we have calculated, for suppose there is some subproblem n with index number 5, n is 8 and index number is 5, and which is previously already calculated, and for that we don't want to repeat the same processing again and calculate that. So we can do the memoize. We can save our answer for that subproblem, and whenever we hit that subproblem we will return that answer from that with O of 1 time complexity. So how we do the memoization is, we can do the DP approach. So in DP we can have n. I'm making an array of size n and having the value -1, and we will pass the DP. And I am writing this in C++. If you are writing Java or anything, like, you don't need to take care of one step, which I will tell you now. you have to pass the DP as a reference, because you don't need the copy of the DP, you need the actual DP itself. So here we will do the DP of index not equal to -1, then we will return the DP itself with the index. So whenever we will hit the subproblem with some index value which is already been calculated, if it is already calculated, then what we will do, we will assign the index value. Whatever this helper will return to us, we will assign that value to my DP. So we will get to know that if our index value is not equal to -1, then we have got some answer for this index value. So that only we will return, and we are reducing our processing time to linear time complexity O of n. So if I will run it, what was the okay, I think I need to give the parenthesis here. Let's check again. Okay, sorry, I have made the DP and I haven't passed the DP here, that's why. Now it will work fine. Yes, now we will submit it, and here we go, it is run, and our time complexity for this will be O of n. And one more thing also we can do here, this is the bottom up I think this is the top down approach or bottom up approach. Please comment me, I am really confused here. We will do the tabulation approach for now. Okay, so in the tabulation approach, we just need we will have our iterative solutions. So we just need our DP here, DP with n, and we can put 0 here. There's no need of -1. We can put it 0, and we will make the DP of n plus 1, because we need n size DP. So if I will do n, then I will get n minus 1 size DP because of the vector indexing. And we can do here whatever are known, like these are known things, that if DP of 0 is 0 only, and DP of 1, there is only one step. Then DP of 2, so we can start the 0 is the 1, our initial conditions, and here we will start from int I equal to 2 to I less than is equal to n, I plus plus, then DP of I here will be DP of I minus 1 plus DP of I minus 2, and at the end we will be returning DP of n. This will give our tabulation. This will be our tabulation approach. Sorry. Okay, and we will submit our answer, and this will be also linear time complexity. Both are fine. But in interview, if you are doing the tabulation approach, this is really appreciated. And thank you for watching my video.